Please go to EliTheComputerGuy.com and FailedNormal.com to see the videos that are too dangerous for YouTube. Welcome back. So in this video, we're going to use a 16:2 LCD screen. We're going to use an analog temperature sensor. And for this, we're going to create a temperature alert system. So imagine we have a server room again. So we have the server room, and if the temperature is in the server room is a particular level or below a particular level, everything is good. So let's say if the temperature is below, let's say 73 degrees, everything's good, the servers are fine, you have no problems. But if the temperature gets between, let's say, 73 degrees to 80 degrees, maybe you want an alert to be notified to know that, oh, the temperature is higher than it should be. Now, if it's below 80 degrees, your servers aren't going to shut down, your networking equipment isn't going to have a problem, but you should be worried. You should be a little bit concerned there. Maybe you have to clean out the air conditioning filter, something like that, to get it back to the level that it should be. So basically, we just want an alert. We just want, hey, the temperature is a little too high. You might want to take a look at this. But then what if the temperature gets above 80 degrees? Above 80 degrees, you got all that, the servers in there, all the equipment in there. That's the point in time that you may start to worry about your equipment either not working as well or actually thermally shutting down and really causing a lot of problems. So in that instance, not only do you want to have a warning, you want to have a warning, but you also want to have an actionable notification. What I mean by an actionable notification is not simply telling the end user that there's a problem, but also telling them what the hell to do. This is one of the biggest problems in the IT world. One of the biggest problems when people create the user experience for notification systems is they'll do things like they'll create red lights. They'll create red lights so the end user knows there's a problem. They absolutely know there's a problem. The problem is the end user really doesn't know what to do about the problem, right? So in this particular project, what we're going to do is once it gets to that warning level, once it gets about 80 degrees, it's going to show the temperature, and then it's also going to flip, and it's going to say, call this guy Bob, and here's his phone number. So not only is there a major problem that has to be dealt with, but here is an actionable task that you can do. Here's the thing, the temperature is too high, call this guy Bob at this particular number. And so this is one of those things that you really have to start thinking about in the IoT world, in the Arduino world, as you design everything. You're designing the interfaces, you're designing how things will be computed, you're designing the output. And so one of the things that you need to think about is, again, you don't just tell the end user that there's a problem. You also tell them what the hell they should do about it. Even if all they should do is call somebody, that's one of the biggest problems in the IT world, is the end user knew there was a problem. They knew there was a problem, they just didn't know who to tell. So what we're going to do in this particular project is we're going to tell them who to call. So with that, let's go over to the workbench. I'll show you the components that we need for this project, then we'll show you the code, I'll show you it all put together, and show you why this is really a pretty cool project. So here are the major components that we're going to need for this project. So of course, we're going to be needing a breadboard. We're going to be needing that 16:2 LCD screen. We're using the Arduino Uno, as we normally do with this particular project. Now again, as with most projects, other boards should work to be able to build this type of project, but in order to run this particular screen, you do need a lot of digital pins, so just make sure you have enough digital pins for whatever board that you're using. Then we're going to be using a single 220 ohm resistor that'll be used for the LCD screen, and then of course a potentiometer. Again, whatever potentiometer you get. This is kind of a crappy one here. The one I use is a little bit better, but you're going to need a potentiometer. Again, this is just a variable resistor. So we put all that to the side. Then we can take a look at how this thing looks actually being built. So I've done other videos talking about how to build all the circuitry for the LCD screen here. And so that's a bit of a pain in the butt. Again, you'll notice you need a lot of wires, you need a lot of jumpers, you have a resistor in here. So there's a lot that goes into building this LCD screen system. So we're not talking about this in this particular project. Go and look at the previous project I've done about that. But basically all we have here is this way is the standard LCD screen project, and then what we've added is we've added the analog temperature sensor down here. Again, we have the positive, we have the negative, and then we have the sensor pin, and that's an analog. Again, analog sensor pin goes to the analog pins. It goes over to A0 on the Arduino board, and so this is what the project looks like when it's built. Let's go over and take a look at the code. So this is the code for this project. Now this code is starting to get a little bit long, but if you go and you take a look at it line by line, you'll realize that it's really not that complicated. And frankly, a lot of it is simply copy and paste from other areas. So if you look at the if, the else if, and the else statement right here, you'll notice most of this is identical. We've just added, or we've modified a few different variables and things in there. So let's go up and take a look at the top. So we're using the LCD display, the liquid crystal display. So in order to do that, we are going to need the liquid crystal.h. This is the liquid crystal library. So pound include the liquid crystal library. The next thing that we're going to do is we're going to define the sensor pin. So this is for the analog temperature sensor. So the sensor pin we are going to put to A0. Then we're going to go down here and we are going to write out a lot of stuff that's required for the LCD screen. So we're going to define all these different pins, R, S, E, N, D4, D5, D6, and D7. These are all pins actually on the LCD screen itself. And then 12, 11, 5, 4, 3, and 2. These are pins that are on the Arduino board. So we're going to define those pins corresponding. And then what we're going to do is we're going to do the liquid crystal, then we're going to do the LCD function, and then we are going to tell the LCD screen where these particular pins are. So this is required in order to make the LCD screen work. More or less, all of this right here, it just is as it is. You just put it in there and you just leave it alone. That's just how it gets written. Then one of the things that we're going to do is we're going to create a variable, an int, for plus minus. So what we're going to be doing with this is we're going to read out the temperature, and then beside that we are going to show whether it's above or below whatever the optimum temperature is. So if the temperature is too high, not only will it say 80 degrees in warning, but it'll say 80 degrees like plus 7. So it's 7 degrees above the optimal temperature. If it's at 60 degrees and the optimal temperature is 73, what it's going to say is it'll say 60 minus 13. Again, this gives you a little bit better idea about how the cooling is working, right? Are you right at the limits? Are you well above or below the limits? Just a little bit of additional information that might be useful to the end users. Then we're going to come down and we're going to set up the environment. The loop is going to run in order to do that. We're going to do lcd.begin, and we are going to say what kind of LCD screen we have. So it's a 16 column, so 16 characters across by 2 row, 2 characters up and down, right? So 16 by 2, and so we use this in order to do like the cursor settings and all that, because you actually have to tell the code where to start typing things out, which can be a bit of a pain in the butt. Then we're going to go down here, and the first thing that we're going to do is we're going to do the standard code for temperature, right? So the standard code for temperature, any kind of analog temperature sensor project, basically copy and paste this in there. Int reading equals, so you're going to analog read from the sensor pin. In order to get, once you get that, you're going to need the voltage. So you create a float, a decimal point. So 10.1, 20.5 or whatever is what a float is. So voltage equals reading times 5. Voltage, you will then take this, that is what voltage will equal, and then you will divide that number by 1024 and then set the value of voltage to whatever the results is. That's what it means when you have something like this. So if it's plus equals, minus equals, divided by equals, times equals, what you do is you do that to this side and then you set the value of the variable to that. Then we're going to create a float for temperature C. So temperature Celsius, voltage minus 0.5 times 100. But here in the US, we use temperature Fahrenheit. So we're going to create a float, temperature F equals temperature C times 9 divided by 5 plus 32. Again, this is all just copy and paste, but going over it a little bit just to make sure everybody remembers. Then what we're going to do is we are now going to go into the if else statement and basically printing things out. This will be printing out the alerts and such. So the first thing that we need to do is we need to use the lcd.clear function. So what this is going to do is this is going to clear the LCD screen. Basically think of this as this is turning all the characters to low, right? So I've thought about that before when you're dealing with like LCD or LED, I'm sorry, LED lights. When you turn LED lights on, you also have to remember to turn them off, right? So if you turn one LED light on in a certain situation and you forget to turn it off, and then you turn another LED light on in a different situation, then all the LED lights are turned on and you never turn them off. You kind of can have the same problem with the LCD screen where if you have text that takes up different amounts of spaces on your screen, then when you flip between different text, some of the characters won't reset. So you'll get some really weird issues. So if you want to just see something curious, if you just want to play around and see something curious, you may want to just delete this lcd.clear function in your sketch when you do it, and you'll see a weird error. You'll be like, what the hell am I looking at kind of error. So the first thing that we have to do is lcd.clear. What that does is that clears the screen. Basically, it turns all the characters on the screen off. So then what we're going to do here is we're going to start with if the temperature is too high. So if temperature is greater than or equal 80, so if it's temperature Fahrenheit is greater than or equal to 80, then what we're going to do first is we're going to take that plus minus variable, and it's going to equal temperature F minus 75. So what this is going to tell us is how many degrees it is above the temperature that's supposed to be. 75 is the standard temperature here. So 75 is the temperature that it's supposed to be. Then what we're going to do is we're going to go down here and we're going to say LCD dot set cursor. So we're going to set where the cursor is going to begin writing from, and that's 0, 0. So remember, when you're dealing with an LCD screen, numbering starts at 0, not at 1. So the first position is 0. So we're doing the first column of the first row. So we're saying 0, 0. And so what we're going to do right now is we're going to do lcd.print warning. So it's above 80 degrees, so it's warning, warning, Will Robinson. Then what we're going to do is we're going to go to LCD dot set cursor. So 0 is the first column. So it's 16 across 2. So it's at the column. So the first position of the second column. So 1 is the second column. And then what we're going to do is we're going to print temp. Then what we're going to do is we're going to do LCD dot set cursor. We're going to go to the, this will be actually the 7th. So it's 6. 6 means 7. So it's the 7th column over on the second row. And then we're going to print the value of temperature F. Then what we're going to do is lcd.set cursor. We're putting in 12, so it means the 13th column on row 2, and we're going to do a plus, so it's higher temperature. And then we're going to do lcd.set cursor 13, so the 14th position on the 14th column on the second row, and we are going to do the value of plus minus. So if this temperature is, let's say it's 85 degrees, then it'll say warning, temperature 85 plus, and since this is the temperature that it's supposed to be, that's the threshold temperature, then it'll say plus 10. Then what we're going to do is we're going to delay, because this is the warning where we have to give some kind of actionable notification to the end user. So we're going to delay for 2 seconds. So that will show up for 2 seconds. Then we're going to do lcd.clear. So we're going to clear the screen. Everything is taken off the screen. Then we're going to do lcd.set cursor to 0, 0, the first column in the first row. And then we're going to say lcd.print call Bob Ross. Call Bob Ross. Call Bob Ross. Now, one of the things you do have to think about whenever you think about these notifications is, remember, you do only have 16 characters. You only have 16 letters. So this is kind of a joke saying Bob Ross is like, oh, ha ha. But something that you have to think about is you've only got so many characters here. You only got 16 characters. So whatever you're saying, it has to fit in 16 characters. And so Bob Ross is a word that, or a name that fit within 16 characters. And so that's what I'm using. But that's something you're going to have to think about. Like, you know, do you put in tech support or do you put help desk? Right? If you're trying to write this out, if you try to say call tech support, that's probably going to be too many characters. Whereas if you say call help desk, that will all fit in. So that's kind of weird stuff you got to be thinking about with the user experience, user interface. Then we're going to do LCD set cursor. So the first column on the second row, LCD print, and then we're going to print a phone number, 111-222-333, whatever the actual phone number is, or an email address, something that is below 16 characters, and then we're going to delay for 2 seconds. So while the temperature is above 80 degrees, for 2 seconds, it will give a warning with the temperature, and then for 2 seconds, it will say, call Bob Ross, and the phone number. Again, something that you have to be thinking about with things like delay is you actually have to give the person long enough to be able to write it down or read it, right? If you just put this for a second, can you imagine if somebody put the delay for a second or half a second and it was just like flipping back and forth? You would have a very pissed off end user. So this is the kind of thing that you have to think about, like thinking about the delay. Like how long do you delay it for 10 seconds? If you delay it for 10 seconds, that's a long time. But if you delay it for 1 second, that's too short. So that's the kind of thing you have to think about with the user experience. Like how long are you going to delay things like the messages for? Then we're going to come down here, we're going to do an else if. So the else if, this is just going to be an alert, right? Else if temperature is less than 80 degrees and temperature Fahrenheit is greater than or equal 75 degrees. So 75 degrees to 80 degrees, this is what's going to happen. So again, we have the plus minus variable equals temperature F minus 75. Then we're going to do lcd.setCursor to the first position, the first column of the first row. We're going to print alert. Then we're going to go to the first column of the second row. We're going to print temperature. We're going to go to the 7th column of the second row. We're going to print the value of temperature Fahrenheit. We're going to go to the 13th column of the second row. We're going to write plus. We're going to go to the 14th column of the second row, and we're going to write the value of plus minus. So this is plus. So if this was 77 degrees, it would say alert, temperature 77 plus 2. So you know it's 2 degrees over the temperature that it's supposed to be. Then finally, we're going to come down to else. So if it's not one of those two things, else it's below 75 degrees. So here what we're going to do is we're kind of, again, you got to remember the math. So we're going to have to swap around the plus minus. So here the idea is temperature is above 75. Here, remember, temperature is supposed to be below 75. So we do plus minus equals 75 minus temperature. So if it's 70, right? So 70 is 5 below 75. So we just have to switch that around for the basic math. Then all we're going to do is set cursor to the first column of the first row. We're going to print out good, because everything's fine, right? Then we're going to go to the first column of the second row, type out temp. We're going to go to the 7th column of the second row. We're going to do the value of temperature Fahrenheit. We're going to go to the 13th column of the second row, and we're going to do minus now because we're under 75. We're going to go to the 14th column of the second row, and then we're going to do plus whatever the value of plus minus is. So if it's 70 degrees, it would print out good temperature, 70 degrees minus 5. So it's 5 degrees under that threshold temperature. Then for here, we're going to delay for 2,000 milliseconds or 2 seconds, and then we're going to loop through. Again, the big thing here with this loop is that you have this LCD clear, so it clears the screen as the values change. So with that, let's upload this thing to the little project, and I can show you how this works in the real world. So the project has been built, the code has been uploaded, and now we're going to give this thing some power. And okay, so now we can see right now, we can see it is good. The temperature is currently 65.17 degrees, and then we have that, so that is below. That's 9 below, 11 below, so we know everything is pretty good here. Then what I'm going to do is I'm going to touch this. That is, of course, going to raise the temperature. We see it go to 67, goes to 71, goes to 74. Now it changes to alert, so the temperature is too high. 77 is plus 2, plus 4 too high. And then once we get to 80, now I have a full-fledged warning. Call Bob Ross, 111-222-333. And basically, again, as long as the temperature is above 80, it will just continue to loop through this. Then as the temperature goes down, we can see that we'll go back to the alert again. So now it's down to alert, 75 degrees. Then as the temperature goes down to cool, then we go down to good. So this is basically how it works in the real world, and I really want you to really be thinking about this. The whole idea of being able to give some kind of actionable response to your end users. Again, not just telling them that there is a warning, not just telling them there's a problem, but telling them what the hell to do. Again, you can have call Bob Ross, you can have email, you can even just have flip on the fan, right? Literally, like you can print out 16 by 2. So whatever, you could just say turn on exhaust fan. You could do something like that, but that tells the end user what they should be doing, not simply that there's a problem. So that's all there is to this particular project. Basically, you just have an analog sensor. Oh, you have the mess of wiring this thing up. Wiring this thing up truly is a pain in the butt, but you know, whatever. You wire this thing up and then you do a little bit of code. Really, with all of this, the base concept here still remains pretty simple. You just have to write out a lot of code for how to print out on the screen. And that's really what programming and coding turns into, right? When you first see some huge program, you know, you see 10,000 lines of code or something, it can be very daunting. It can make you very worried. You can think, oh, I'll never be able to do that. But what you realize is a lot of code in there. You've got a lot of duplicate code. You have a lot of code, again, where basically you take a whole chunk of code and then you paste that to the else part of the if-else statement, and then you simply modify a couple of things in there. And really, even when you look at the code itself is relatively simple, even if it is a pain in the butt to write. You know, you have to set where the cursor starts. Then you have to write out what you want to write out. Then if you want another word, you have to figure out where the cursor should start on that second word, and then you print that out. And then the third word, you figure out where the cursor starts on the third word, and you print that out. And then if you have 2 rows, then you got to go down to the second row. And so, you know, if you look at that, what you realize is it's really simple. It's really simple. It's setting where the cursor is and then saying what should be printed out. It's just very verbose to get it done, right? It takes a lot of code to get something that seems relatively simple accomplished. So that's one of the reasons why you shouldn't be too daunted when you look at coding or anything in technology, is just realize everything in technology at its core is relatively simple. It's relatively simple items that get stacked together to make a very complicated project. All you have to do is you have to start, you have to think about all the things that need to happen, and then you write out all the parts for those individual things, and then at a certain point you actually have something that seems pretty impressive. So that's all there is to this particular project. One of the big takeaways I want you to be thinking about from this project, though, is again, what information can you give to the end user that they can do something with? One of the most frustrating things I see in the IT world is you see these technology professionals and they'll create alerts. There'll be red lights, and there'll be alerts, and there'll be pings and text messages and all kinds of stuff. But the end user doesn't know what to do with it. The end user's like, well, I knew the server room was 105 degrees. I saw it. I saw the warning. I saw it was 105 degrees. But I didn't know what I was supposed to do. And then you get the IT for, oh, didn't you read on page 500, you know, appendix A of the user manual, that if the temperature is above X amount of degrees, you should call this person? And it's, no, I didn't read that manual. I didn't know we had that manual. Does that manual still exist? Right? So if you can give your device, if you can allow your device to actually communicate to the end user and give them actionable things to do, that will make everybody's lives a hell of a lot better. So, as always, I enjoy doing this video and look forward to seeing you at the next one.